Hi everyone, Meteorologist Joel Curtis from the National Weather Service. I'd like to talk to you folks today about fire weather, and let's have a little introduction to that. First of all, why do we do fire weather? Fire weather is a little different in that there's three components to it that are very important. One is the weather itself, the topography, and the fuels. Now, the weather is the most variable thing that there is in there, and the weather is also impacting the fuels. We have several fuel types, but they work from the ground up, and what we want to do is understand the fire behavior, first of all, for safety. You may need evacuations or people need to respond to the fire, but also by understanding what the fire behavior is doing, we also are able to better and efficiently suppress that fire, put it down when we have to put it down. And so with the different fuels, there's a time lag in these. So essentially, the more mass of the fuel and the longer out it is in such a way, it takes less time to dry. For example, grass only takes an hour, whereas thick logs take about 1,000 hours. And then we have to consider the terrain. So first of all, there's the aspect. What direction is the terrain facing, and how is that with respect to where the sun is shining? Because clearly when the sun is on a slope, it's able to heat better than when the sun is on, like, let's say, flat land. And then the second thing is that the slope really also impacts fire behavior. You have preheating as it goes uphill. You have a draft that will go uphill with the heating of that terrain. Fresh air is coming in from the base of the fire if it's in terrain, and then chunks are rolling down the slope. So this really affects the fire behavior by faster ignition and spread going uphill. So, fire weather, monitoring, and the forecast. Well, first of all, we're trying to pin down the season transition to a warmer and drier regime. And that'll give us the onset of the fire season. Now we're starting to look out and be aware of the fire, and also the prediction of the season intensity. How is this season going to go compared to last year or many years? And then, most important is the short-term fire danger potential. And the sign on the right of your screen there is typical of the signs that you see by the various fire agencies out for public view. We want to pin down the individual fire behavior on each fire. And that is the spread and the intensity so that it can be better fought and we'll get evacuations going where they need to be done. Also, we have to consider too a strategic distribution of the resources that we have to fight the fire. That would be aircraft, fire crews, etc. And they're at the local, area, state, and national levels. Well, I've often heard a lot of people will come and say to me, well, you're a fire meteorologist, you know, the fire makes its own weather. Well, not quite. In the short term and the season, the weather sets up the potential for the fires. Often the ignition is human caused, but also in Alaska, in wilderness fires are generally ignited by lightning. And after the fire grows and increases in intensity, then wildland fires have their feedback weather. And so let's take a look at the weather elements to show how this takes place. First of all, wind. It's the most dynamic of the weather elements. It pushes the flames into new fuel, increases the oxygen, transports heat by drying the fuel downwind, and it also transports burning embers, which causes spot fires. And nothing is more dangerous to the fire crews out there that are trying to suppress the fire when you have embers that are lofted in the atmosphere and the wind takes them behind you where you're building the fire line. And that cuts off escape routes. So very dangerous, and we're always thinking of wind when we're on wildland fires. So now humidity. It's the amount of moisture in the air compared to what the air can hold. And that's the percent called relative humidity. Fine fuels like grass gain and lose moisture very quickly, and the heavy fuels are much slower, both to gain the moisture and then to dry it out. Low humidity fuels dry fast and are more flammable. Live fuels are more moist than dead fuels. Now for temperature. Higher temperatures heat and help to dry fuels to increase the ignition. Areas of higher temperatures can drive the wind. So in other words, air is rising over a warm area and the wind will follow that air to blow in. There can't be holes in the atmosphere. Also, hot temperatures cause stress and hydration problems to the suppression personnel. And also in Alaska, we have to consider burn period because our days, our solar days are so much longer that we can have a much longer burning period than, let's say, in the lower 48, where the sun rises and sets and you have a genuine nighttime. Now, for sky cover and solar input, the sunshine heats and dries the fuel and naturally increases the temperature. Clouds prevent solar heating and suppresses the temperature increase. Smoke, however, and I've been on a number of fires that have done this, can actually shade the fire and suppress the fire a little bit. Also, the aspect, which direction the slope is facing where the fire is, can really affect the temperature. So then we have to consider atmospheric stability, and this is where most of the feedback, people say the fire creates its own weather. Well, it's the atmospheric stability that will cause that feedback. So a stable atmosphere resists upward and downward motion and keeps the fire fairly predictable. But then meanwhile, an unstable atmosphere where the air is, we have currents either going up or down, really causes some problems in the predictability of the fire. And then the fire, as it increases intensity, will actually increase those winds that are blowing toward the fire because the air is rising so rapidly over the fire. And you can see that in the smoke columns. And eventually, you can get to a thunderstorm occurring over the fire. And the technical term for that is called pyrocumulus. So lightning ignition can actually ignite fires around the fire that's already going. Updrafts and vortices will cause wind toward the fire, and the vortexes, there was, I've seen fires where there actually have been fire whirls and even fire tornadoes. In the meantime, the downdrafts and outflow out of a thunderstorm can actually cause the wind to go out of control, and this is very dangerous for the firefighters that are on the fire line. Yet, rain can also suppress the fire activity. So, of all the things, when I'm out on a wildland fire and predicting the weather that I worry about, thunderstorms is the biggest. How about precipitation? Well, of course, rain and snow can raise the moisture and content of the fuels and can slow down or even extinguish the fire. But light precipitation can leave the heavier fuels and the duff, the litter down there on the ground from the leaves and pine needles and whatever, in a previous state and not affect it very much. And then the worst thing is that where you have a burn scar, they're less resistant to flash floods and debris flows. So that can be a very dangerous situation as well. So in summary, weather, fuels, and terrains are the components of wildland fire. Each weather element has a contribution to the behavior of the fire, and we want to know that behavior of the fire both for safety and to efficiently fight it. So the forecasts are vital to the prediction of fire behavior. And you can find us on Facebook at NWS Alaska, X at NWS Alaska, and you can also get YouTube at NWS Alaska. Thank you very much for attending.